Hello, welcome to another math video. So we are going to be going through the P2 learning guide, and that is the section on exponents and scientific notation. So in this section we're going to make use of quite a few exponent rules, so I'm going to go ahead and start off by just going over the ones we're going to use. So let me write down a few exponent rules that you might remember from one of your previous math classes. So exponent rules. Okay, so remember exponents just stand for how many times you're multiplying a repeated factor. So the first one is if we have something like a to the m power times a to the n power, this is going to equal a to the m plus n power. So an example of this is if you'd have 2 to the third power times 2 to the second power. Really, we've just got 1, 2, 3, 4, 5 copies of 2 all multiplied together. So this is 2 to the fifth power. So that's how you would simplify them, and if you notice, that's all we're really doing is adding the exponents of the first factor with the exponents of the second factor. A very similar one is if we would do division involving the same sort of factors, a to the m times a to the divided by a to the n. We are just going to end up with a to the m minus n factor. Really, we're just canceling repeated factors in the top with ones in the bottom. So if you would have like 5 to the third power divided by 5 to the first power, you'd cancel one of the 5's with one of the ones on top, and you just end up with 2 copies left. Remember, if you don't write an exponent with a number, it is just kind of understood that that exponent is 1. Okay, third rule. If we have a to the m, and then this whole business raised to the nth power, what we do here is we actually multiply the exponents. So this will be a to the m times n power. And you could see something like that if you had 2 to the let's say third power raised to the third power. You would have 3 copies of 2 cubed, which would give you 1, 2, 3, 1, 2, 3, 1, 2, 3, 9 total copies. So what we're doing here is we're multiplying the exponents. So it's really important that you don't confuse rule number 1 with rule number 3. That's one of the most common mistakes you'll get when people are applying these exponent rules. They'll just decide that you're always supposed to add the exponents or always supposed to multiply them, but just remember that there are 2 different rules. Number 4 is kind of one where you have to distribute the exponents. So say you have multiple things multiplied inside parentheses. What you have to do here is you actually have to raise each one to the nth power. So it's like you're distributing the exponent across the parentheses. So why do we distribute exponents like this? Let me kind of do a little example. So let's say we have AB, and let's just raise it to the third power rather than the nth. Well, what does this really mean? This means we're doing AB times AB times AB. And since everything is multiplied together, it really doesn't matter which order you do it in, right? 2 times 3 is the same thing as 3 times 2. That's the commutative property of multiplication. So basically, we're just going to move all the a's next to each other and all the b's next to each other. And we end up with a to the third power times b to the third power. Just like our rule says. But our rule uses n's instead of 3's, but really it's the same point. Okay, 2 more rules that will pop up late in the learning guide. One is when you take anything to the 0 power, it equals 1. And the 6th rule deals with negative exponents. So an important thing there. So if we have a to the negative nth power, that equals 1 over a to the positive nth power. Or if we would have 1 over a to the negative nth power, that's just equal to a to the nth power. So the important thing here is the negative exponent is just telling you it goes in the other part of the fraction. it's important to realize that this has nothing to do with a number being negative in itself. Frequently the number is going to be positive. So for example, if you would have 5 to the negative second power, this would just mean 1 over 5 to the positive second power, which is 1 over 25, or if you would want to make that a decimal, 0.04. So it's important to realize that even though we have a negative exponent, that says nothing about the sign of the number. The reason you have negative exponent notation is just because it basically means multiplicative inverse. Alright, so let's go back to the learning guide and see if we can do some of these problems, knock them out. Okay, I think this is where we were. That's section P1, so let's go down to P2. Alright, section P2. This is what we want to do. And remember, for any of these learning guides, you have a solved problem on the left, and we're going to do the pencil problems on the right. So I suggest, if you want to kind of do active learning and study along, that you look at the solved problem, then go ahead and do the pencil problem, and pause your video and see if you get the same answer as me. So this first example, we just have two things with the same base, so what we're going to do is use rule number 1, and this says this should just be x to the 3 plus 7th power, which is x to the 10th. So very straightforward. 1b is a little more complicated, and what we want to do here is we just want to always kind of put the things, if everything is multiplied together, put the things that look alike next to each other. So what do I mean? I mean, well, let's put the regular numbers next to each other, -9 and -2, and then let's put the x cubed next to the x to the 6th and the y next to the y to the 4th. And now that's all we have is a bunch of iterations of that exponent rule number 1. So we just need to add some exponents. So -9 and -2, when you multiply those, you get +18, x to the 9th power, and y to the 5th power. So remember, since that y doesn't have an exponent on it, it really just means the exponent's 1. Okay, now here's some examples of rule number 2. So what we want to do is just make sure we subtract top exponent from the bottom, or the bottom exponent from the top, rather. So this should be 2 to the 8 minus 4 power, which is just 2 to the 4th power. So that is equal to 16. Alright, the bottom one we want to do the same way. We want to associate the regular numbers. So we know that 25 divided by -5 is -5. Then we want to do a to the 13 minus 2 power times b to the 4 minus 3. So we just end up with -5, a to the 11th, and b to the 1st power, which we just write as b. Alright, -3 to the 0 power, well, that's easy. Anything to the 0 power is equal to 1. Let me ask you kind of a separate, trickier question. How about -3 to the 0 power? So is there a difference between -3 and parentheses to the 0 power and -3 with no parentheses raised to the 0 power? Well, this one actually equals -3 to the 0 power equals -1, if you can believe that. And the reason why is we think about the negative as actually an example of multiplication. So the trick here is to remember PEMDAS, the order of operations rule. And why does that make a difference? Well, this 0 is an exponent, and we're going to apply it to the 3 before we multiply the negative sign. So really we're raising 3 alone to the 0 power, giving us 1, and then the negative comes after. Whereas in the example before, the parentheses say we multiply by the negative before we apply the 0. So in the example for pencil problem number 3, you get +1, but in this extra example I wrote, you would actually get -1. So keep that in mind. Okay, notice the rules for number 4 say write with a positive exponent. This is pretty common. Aesthetically, it's usual to see the answer asked for so that your answers have a positive exponent. So Here we want to do 1 over 4 to the positive 3 power. Remember, you can make the exponent positive by just putting it in the opposite part of the fraction. And then we know 4 to the 3rd power is 64, so this is 1 over 64. Okay, for b, not only do we have a negative exponent, but we also have multiple factors inside parentheses. So we have to go back to our exponent rule sheet and make sure we distribute that negative first. So we're going to start by raising every single thing to the negative power, negative second power. So we have 4 to the negative second power, and then we also need to raise the x cubed to the negative second power. 4 to the negative second power we know is 1 over 4 squared, and the second part we need to multiply the exponents, so x to the negative 6th. So we end up with 1 over 16 times 1 over x to the 6th. And since we have two fractions and the tops are 1, we can just multiply and write this as 1 over 16 x to the 6th. And notice all of our exponents, just the 6, is positive. Okay, simplify using the power rule. So this is just the one that says when you have something inside parentheses with an exponent, we need to multiply them. So this is just 2 to the 2 times 3, which is 2 to the 6th power, which is 64. Quite a common number today in the examples. Okay, 5b, let's do this one. So we just multiply and we get x to the negative 15th. And just for practice, let's write that so it's got a positive exponent, so it would be 1 over x to the 15th power. Alright, next one, things get a little bit more complicated, so remember we need to distribute that 2 over the parentheses to each factor. So you have an 8 squared, and then you have x cubed squared, and then just use the rule that says to multiply the 3 and the 2. So you end up with 64 x to the 6th power. 64s, they're popping up everywhere. Watch out. Okay, number 7. Again, we're going to need to distribute that 3. Oh, excuse me. But the thing here is we've got a fraction and also a negative sign. So even though I didn't write down a rule for this, it's pretty standard. You do what you expect. We're going to need to distribute that 3 everywhere in the fraction. And often it's helpful to write that negative sign as just a negative 1. Remember, negative is the same as multiplying by negative 1. So we're going to have negative 1 to the 3rd power times 4 to the 3rd power over x to the 3rd power. So notice we distributed that 3 every single possible place it could go in the parentheses. So let's go ahead and evaluate. So any negative to an odd power always just stays a negative sign. So we have negative 1 times, and then the fraction is 64 once again over x to the 3rd power. And usually we don't write the negative 1 out front. We just keep it as a negative in front of the fraction. Okay. Number 8, even more complicated. All kinds of stuff to distribute the 2 to, but just go one step at a time. So we have the negative 3 squared, and you can split that up if you want. Negative 1 squared times 3 squared, but it's the same if you just do negative 3 squared. Then we have to square x squared and square y to the 5th. So we end up with positive 9 x to the 4th y to the 10th, and that's our answer. Okay, 8b. Okay, so this is one where we have multiple parts multiplied together, both in parentheses. Nothing raised to an exponent outside the parentheses, so we don't need to distribute. So let's just go ahead and get the regular numbers together, 3 times 2, and the x's together, x to the 4th times x to the 7th. Regular numbers we can just multiply, and the exponents we add in this case. So 6x to the 11th. 8c, very similar, but we're going to have to use the subtraction rule instead of the addition rule. So we're going to start by doing 24 over 32, and then I'm just going to separate these into 3 different parts, but we can put them all back together at the end. So x to the 3rd over x to the 7th, and y to the 5th over y to the negative 9th. So we have 24 over 32, that is the same as 3 over 4 if you simplify it. You can take an 8 out of 24 and an 8 out of 32, and you're left with 3 on top and 4 on the bottom. The x, we're going to do 3 minus 7, and the y, we're going to do y to the 5 minus negative 9. So we end up with 3 over 4, x to the negative 4, y to the 14. And basically, remember, if we want to keep our exponents positive, the ones that are already positive stay on top, and the ones that are negative go on the bottom. So this will end up as 3y to the 14th over 4x to the positive 4th. Alright, 8D. We need to, oh man, I'm drinking coffee right now, it is so delicious. We need to take this negative 2 and distribute it to all parts of the fraction. So we're going to do 5 to the negative 2, x cubed to the negative 2, and y to the negative 2. So this ends up as, remember, so let's write this as 5 to the negative 2, x to the negative 6, and y to the negative 2. So notice all of our exponents are negative, so we want to make them positive, so just put them on the other parts of the fraction. So the y will come up to the top and be positive, the x will go to the 5 will go to the bottom, and the x will go to the bottom. And then we can expand the 5 squared into 25. So y squared over 25, x to the 6th. Okay, so the last thing to talk about is scientific notation. And for scientific notation, I basically like to use the rule, use common sense. So basically the 10, the exponent of the 10, is going to tell you how many places you need to move the decimal. And if you're not sure which way it should move, just use common sense to think about what kind of number it is. 10 to the 6th is a really, really big number here. That's a million. So we know this 7.16 should have a larger modulus. I mean, its absolute value should be much, much bigger when we're done turning it into a decimal. So here what we're going to do is take the 716, so we've moved the decimal 2 places. The exponent was 6, so we need to move it 4 more, so that means add 4 zeros, because this should be a really big number. So we end up with negative 7,160,000. Alright. And just double check by saying, okay, this is big, and we're multiplying 7.16 by something big, so that makes sense. Here we have 7.9 times 10 to the negative 1st. So 10 to the negative 1st is 1/10. So that should be making whatever our number we have smaller. So this will turn into 0.79. Notice 0.79 is smaller than 7.9. And again, this shows that just because you're multiplying by something with a negative exponent, the final answer is still positive. So that has nothing to do with an actual negative sign. Okay, now how about changing a number from decimal form to scientific form? Well, what we want to do is we want to write it as a number between 1 and 10, whose number is absolute value between 1 and 10, and then multiply by the appropriate 10 to a power. So here, the only regular numbers we have are 3, 2, 32. So we're going to make that 3.2. That's the only way to get a number between 1 and 10 with the non-zero part of our number that we start with. And then what do we need to multiply this by to get back to 32,000? Well, we moved the decimal 4 places, and 3.2 is a whole lot smaller than 32,000, so we know we need to multiply it by a big number. So 3.2 times 10 to the 4th. Let's come down to 9b. So we've got a really, really tiny number here, and it's negative, so the negative just stays out in front. Only way to get a number with these 3 non-zero components is to do 5.04. And then we have to figure out, so this is a much bigger number than the number we started with, so we know our exponent of 10 is going to be negative. And then we got to figure out how negative is, or how many places did we move the decimal. Well, you just count. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So it's going to be 10 to the negative ninth power. Okay, let's continue. So the last two examples in this lecture actually involve the arithmetic operations. So this is going to work just like the exponent examples we did. Just put the regular numbers together. So everything's multiplied, so in this case we'll multiply 1.6 and 4, and then we'll bring the 10s all the way to the right, 10 to the 15th times 10 to the negative 11th. And since these two look alike, we can just add the exponents using that exponent rule number 1. So 1.6 times 4, that is 6.4, so there's our favorite number appearing again in disguise. Instead of 64, we have 6.4, and then times 10 to the 15 minus 11 gives us positive 4. So 6.4 times 10 to the 4th power. And then the last example is similar, but it's division, so we're going to do 2.4 over 4.8. So notice 2.4 is half as big as 4.8, so that's just 0.5 times 10 to the negative 2 minus negative 6. So we end up with 0.5 times 10 to the 4th. Notice, though, they asked us to put the number in scientific notation, and this one is not in scientific notation because that number out front, 0.5, is not between 1 and 10. So what we really need to do is take one of our copies of 10, and then we'll have 3 copies left over, and multiply that with the 0.5. So this part right here is just going to become regular 5. So we end up with 5 times 10 to the 3rd power. Alright, so that is it for this section. P2. So I hope you enjoyed working with the exponents in scientific notation. I will see you in lecture P3.